There are more stars in the universe than grains of sand on every beach on Earth. Billions of galaxies, each one with billions of planets. And yet, as far as we know, we are completely alone. Not one signal, not one probe, not one sign that anyone else is out there. This is called the Fermi Paradox. And once you understand it, you'll never look at the night sky the same way again. Let's start with the numbers. Our galaxy, the Milky Way, has somewhere between 100 and 400 billion stars. Most of them likely host at least one planet. That means our galaxy alone probably contains tens of billions of planets sitting in the habitable zone, not too hot, not too cold, just right for liquid water. And the Milky Way is just one galaxy. There are an estimated 2 trillion galaxies in the observable universe. Even if intelligent life is incredibly rare, say 1 in a billion planets, the math still leaves us with millions of civilizations that should exist right now. In 1961, astronomer Frank Drake tried to put a number on this. His equation multiplies things like the rate of star formation, the fraction of stars with planets, and the odds that life evolves into intelligence. Even with conservative estimates, the answer keeps coming back the same way. The galaxy should be full of civilizations. Many of them should be millions of years older than us, old enough to have colonized entire star systems, old enough to have sent probes or signals of some kind. So here's the question. Physicist Enrico Fermi famously asked back in 1950, while discussing this exact idea over lunch with colleagues, "Where is everybody?" For over 60 years, we've pointed our best instruments at the sky. The SETI project alone has scanned millions of star systems for radio signals. The result? Silence. Total, complete silence. No signals, no megastructures, no sign of energy being harvested on a massive scale. Nothing. Given how old and vast the universe is, that silence is strange. Some scientists call it the Great Silence, and it demands an explanation. One explanation is called the Great Filter. The idea is that somewhere between dead matter and a civilization capable of spreading across the galaxy, there's a filter, a step so difficult that almost nothing makes it through. Maybe the filter is behind us. Maybe the jump from simple cells to complex life was so unlikely that Earth is one of the only places it ever happened. Or, and this is the unsettling version, maybe the filter is still ahead of us. Maybe every civilization that reaches our level of technology eventually destroys itself. Nuclear war, climate collapse, runaway AI, or something we haven't even thought of yet. If the filter is ahead of us, the silence in the sky isn't comforting. It's a warning. A gentler explanation is the rare Earth hypothesis. It suggests that while simple microbial life might be common, complex intelligent life needs an almost absurd number of coincidences to happen. A large moon to stabilize our tilt, a magnetic field to block radiation, a giant planet nearby to absorb incoming asteroids, a stable sun, the right chemistry in the right place for billions of years. Stack enough of these coincidences together, and maybe Earth isn't just rare. Maybe it's a genuine one-in-a-universe fluke. Then there's a darker theory, popularized by the science fiction novel The Three-Body Problem, the dark forest hypothesis. Picture the universe as a dark forest at night. Every civilization is a hunter, and every hunter knows one rule. Any other hunter you find is a potential threat, because you can't know their intentions. And by the time you find out, it might be too late. So the safest move for any advanced civilization is to stay silent. Don't broadcast your location. Don't respond to signals. Under this theory, the silence isn't emptiness. It's civilizations hiding from each other for survival. A slightly stranger idea is the zoo hypothesis, that advanced civilizations already know we exist, but deliberately avoid contact, the same way we might observe a nature reserve without interfering. Oh, maybe we're simply too primitive to be worth talking to yet. Maybe there's a cosmic version of a prime directive, and we just haven't passed the test. Nobody knows which explanation is correct, or if the real answer is something we haven't even imagined yet. But here's what makes the Fermi Paradox so unsettling. Every explanation is either humbling or terrifying. Either intelligent life is so rare that we are essentially alone in the observable universe, or it's common, and something eventually wipes it out every single time. Next time you look up at the night sky, remember, Those billions of stars aren't just beautiful. They're a question we still can't answer. Where is everybody? That's all today. See you in the next video. Till then, stay happy and be healthy.